Of course, you can have a metabolic acidosis without an elevated plasma ion gap. And some of the best examples of those happen in the kidney. These are renal tubular acidoses, of which there are 3 types that we need to discuss: type 1, type 2, and type 4. To compare these, the best thing to do is to think about where does the problem lie. It just so happens that type 1 renal tubular acidosis is a problem with acid secretion, while type 2 renal tubular acidosis is impaired bicarbonate secretion, and type 4 is also impaired acid secretion. If you can keep these as straight as possible, you'll hopefully be able to better diagnose what your renal tubular acidosis might be. So 1 and 4 impaired acid secretion, type 2 bicarbonate secretion. The disorders that are associated with these can be numerous. Many of them involve some genetic disorder. Rheumatoid arthritis is oftentimes associated with type 1 renal tubular acidosis. Some drugs, such as carbonic anhydrase inhibitors, are associated with type 2 renal tubular acidosis. And for type 3 renal tubular acidosis, Addison's disease is a great example of trying to tie those together to a clinical condition. All of them will respond with a renal tubular acidosis is a metabolic acidosis. You notice we didn't mention type 3, right? You won't see it. To summarize the acid-base disturbances, we can utilize this type of a chart. A respiratory acidosis always involves a decrease in pH, a small increase in bicarb, and a large increase in carbon dioxide. A respiratory alkalosis is an increase in pH, a small decrease in bicarb, and a large decrease in CO2. Metabolic acidosis is a decrease in pH, a large change in bicarb, with no change in CO2. A metabolic alkalosis is an increase in pH, a large increase in bicarb, with really no change in PCO2. The other thing to keep in mind with summarizing these acid-base disorders, you have an initial disorder, and then you might have a response to it. If you think about the diagrams, it will always help you try to predict what the compensation is going to be. So you have your 4 primary disorders that we just covered in the table. You have a respiratory acidosis, respiratory alkalosis, metabolic acidosis, metabolic alkalosis. How are you going to try to fix these problems? Well, a partial fix usually involves the opposite system. So if you have a respiratory acidosis, you try to fix it with a metabolic alkalosis. If you have a metabolic acidosis, you try to fix it with a respiratory alkalosis. If you have a metabolic alkalosis, you try to fix it with a respiratory acidosis. And finally, if you have a respiratory alkalosis, you try to fix it with a metabolic acidosis. Partial compensation means you are moving your pH back towards normal, but you may not have reached normal yet. Once you reach normal, it's called perfectly compensated. I would like to say that we usually become perfectly compensated, but life is not perfect. Usually you partially compensate and eventually are trying to move back to normal ranges, and oftentimes you never get there. But you're trying to do that process. The last type of disorder that I'm just going to bring up as a problem that happens is if the disorders are mixed. Mixed or compound disturbances mean that you have more than one problem. And these are very serious conditions. A type when you could have a respiratory acidosis and a metabolic acidosis at the same time. Those are very hard to fix because both systems are moving pH in the same way. Just like if you had a metabolic alkalosis with a respiratory alkalosis at the same time. Again, very hard to fix because you have multiple compound problems.